So let's start our discussion with limits. So whether you like it or not, in your test 2 there will be a question for limits. Whether you're doing 1100, 1120, there will be a question under limits, whether you like it or not. That's what you need to know. So limits is one of the simplest subtopic under calculus that you guys are supposed to know. Okay? So some of the most important questions that I want you to know under limits are just few. Limit as x approaches a number, and limit as x approaches infinity, as well as limit as x approaches 0. That's all. Okay? I'll give an example. If at all we've been given a question to say limit as x goes to 2, maybe we have got x squared minus 2. When we say x approaches 2, as x gets closer to 2, what is the value of y? In this case, as long as I can plug in 2 and then this function is not going to be undefined, I can go ahead and plug in values. That becomes 2 to the power 2 minus 2. 2 to the power 2 is 4 minus 2. The answer is 2. I only stop introducing limit when I want to plug in the value. As simple as that. So I've received the throw sheet. Thank you. You only stop introducing limit when you want to plug in the value. Does that make sense? Yes, it does. But in a situation where you have got a situation 0 over 0 and a number over 0, this situation take us to what? Undefined. That is undefined. Now we need to find a way on how we are going to run away from undefined to make the function to be defined. Okay? For example, a simple example that I can give you whenever we're talking about undefined thing is this. If at all I've got limit as x goes to 5, then I've got x squared minus 25 divided by x minus 5. If I plug in 5 direct, I'm going to get a scenario where I'm going to have 0 over 0. That is undefined. How can I run away from undefined? Okay? I know that what I have on top there, I need to find a way on how I'm going to make this function to be defined. And that will be x to the power 2 minus 25 is the same as x squared minus 5 raised to the power 2. If there is minus, that is a difference of 2 squares. What do we mean when we say difference of 2 squares? Difference of 2 squares is x minus 5 and x plus 5. So then I can replace, if I expand this, it will take me back to x squared minus 25. Meaning that I'll keep on bringing limit as x goes to 5 of x minus 5. I put it in brackets, then x plus 5. I divide that by x minus 5. I can clearly see that on top there I've got x minus 5, down I've got x minus 5. These two can go. Now what do I have? As you can see, you should keep on bringing limits. Even here I'll keep on bringing, I'll say limit as x goes to 5. I've remained with x plus 5. When you want to plug in the value of x, you stop introducing limit. You just say equal to 5 plus 5. That gives me what? 10. That's my answer. At your own free time, I want you to go ahead and you go and solve this. Limit as x goes to 2 of x squared minus 4 divided by x minus 2. Go ahead and solve this at your own free time. Now, another scenario that I want you to get or to be familiar with is when we're talking about this. What if I have got limit as x goes to 2 of x to the power 3 minus 8 divided by x minus 2. If at all you have got a raised to the power 3 minus b raised to the power 3, we use a certain formula. So I can clearly say that x to the power 3 minus 8. 8 is the same as, so this will be 8 to x to the power 3 minus 2 to the power 3. This gives me to the same as that one. X to the power 3 minus 2 to the power 3 is not the same as x minus 2 raised to the power 3. These are not the same thing. They are different. I want you to know that. I mentioned earlier to say x to the power 2 minus, what did we had 25. So we said this is x to the power 2 minus 5 to the power 2. This is not the same as x minus 5 raised to the power 2. They are not the same. This is a difference of two squares. This is not a difference of two squares. I want to make you to understand that part. So I'm saying if at all I have got a to the power 3 minus b to the power 3, I can use a certain formula. And that is going to be helping me to plug in anything when I've got x to the power 3 minus a number. Just know that that number, you need to find a certain number that you're going to raise to power 3. It should give you that number. For example, 8. 2 to the power 3 is 8. So wherever you have got a to the power 3 minus b to the power 3, this gives you a minus b. You put them in brackets. Then a squared plus ab plus b squared. That's what it means. In this case, my a is x. I'll put x. My b is 2. My a is x. Now I square it, is x squared. Plus ab. A is x. B is 2. So meaning it is 2x. B is 2. Now 2 to the power 2 is 4. I'll replace this guy with what I have on top. I can clearly see that x minus 2 down there is going to be eliminated and my function is going to be defined. You see how interesting these things are. These are the questions you are expecting when it comes to limits. Hello. You can hear me. Okay. So then if I continue with this question, keep on bringing limits like I said. You guys, who do you think is going to win on president? Eh? So limit as x goes to 2, I will replace this with x minus 2, x squared plus 2x plus 4. I divide that by that. Oh, x minus 2 and x minus 2 will go. Keep on bringing limits. Don't stop. Keep on bringing limits. Limits as x goes to 2, x squared plus 2x plus 4. Now I want to plug in 2. Stop bringing limits. Just say equal to 2 to the power 2 plus 2 times 2 plus 4. 2 to the power 2 is 4 plus 4 plus 4. What answer are we going to get? 12. These are the basic ideas. These are the things you are supposed to know. These are the things you're supposed to know. At your own free time, I want you to go ahead and look at this question. Limit as x goes to 3 of x minus 3 divided by x to the power 3 minus 27. Even just by looking at it, other people can solve. But using the concept I've given you, I want you to solve this question. I'm going to open the group. You'll be able to post the answer in the group. Take a screenshot of this question. Okay? Take a screenshot of this question. I want you to look at that question. Okay, now let's talk about limit as x approaches to infinity. I'll give you a very simple example. Limit as x goes to infinity of 1 over x. Yes, please.
Yes, so on that part, I'd say x minus 2, the first bracket, the on the second bracket there, x squared minus 2x plus 4. Were you trying to like expanding x minus 2 squared or what?
Ask your question again.
I'm saying uh on the it should be the second or third step is so the first bracket there's x minus 2, and then the second one it's x squared minus 2x plus 4. So where's the 2x coming from?
Okay, it's a good question. Not so. But you saw the formula that I wrote about a and b, the one I said a to the power.
Yes,
Can you remember it? You can remember it? You can tell me the formula?
maybe someone else can tell you. I forgot it.
Oh, so that's the reason now. I've seen the reason why you're asking. So, but anyway, so
Think, sir,
mhm,
I think the formula you are talking about is a to the power 3 minus b is equal to open brackets, a
mhm,
minus b, close brackets,
mhm,
open brackets,
mhm,
a to the power 2
mhm,
plus ab
mhm.
plus b squared, close brackets.
So we are using this formula, my friend. So in this case, this is our a and that's my b. So I'm just plugging in a is x, b is 2. Then again a is x down to the power 2, which is x squared. A is x, b is 2. 2 times x is 2x. Then b is 2, so 2 squared is 4. That's where 4 is coming from. Have you seen it?
Yes, I've seen.
Okay, thank you. Now, whenever we're talking about limit as x goes to infinity, what I want you to understand is that infinity is not necessarily a number, but it represents a very big figure. For example, we can say it represents maybe 100. It can be 1000. It can be even 10,000. So if you look at this, if I plug in a number, let's start with 100. Another one I'm going to plug in 1 over 1000. Another one I'm going to plug in a 10,000. I want us to get the answer. This is going to be 0.01. Then this is going to be 0.0001. This is going to be 0.00001. Initially, if I round it off all these numbers, I'll end up having what? 0. Not so. Are we in support with that? Are we in support with that? If I round off these numbers that I'm finding here, I'll end up getting 0. Not so. Hello.
Yes, sir, you're going to get a 0.
Mangarazima ninka. You are still thinking of Koshes and Albisho. Oh. But okay, cool. Can you imagine yourself? You are blank in math and physics, and then you want me to teach you physics. You don't know anything. Then I come through to teach you. I even come physical. in one of these venues, then I teach you, you even go and clear. Now the only thing that can work, that can make that to be possible is when our Bishop and Cautious pull through, because they're the same people who are going to find the venue for me. Then you have just to eat and come and sit. Okay, so now what I'm trying to tell you is any question which involves limits, I want you to understand one thing. We are trying to make x to be on the denominator. Then when x appears on the denominator, meaning that the answer is 0. That's the basic idea. Under functions, some of you were failing to understand when we tell you to say what is the vertical asymptote. If you don't know how to find the horizontal asymptote under functions, if you don't know how to find the range under function, there are two things, right? If you don't know how to find the range under function, you don't know how to find the horizontal asymptote under functions. If you have got any function, then just take that function to say limit as x approaches infinity. The answer you're going to find, that is your horizontal asymptote, and that is your range. So when you find the answer, I'll give you a very simple question. A very simple question that I'm going to give you here about limit x goes to infinity. Limit as x goes to infinity, you can answer it even if you don't know how to answer. If you know how to find the vertical asymptote, then you will be able to know to say, okay, so this is the answer. You get my point, right? So now it's more like we are doing a revision. I'm teaching you two things. I'm teaching you two things right now. So where is the question now? Here is the question. Here is the question. So the question is, limit as x goes to infinity of 5x plus 1, I divide it by 10 plus 2x. For those people who can be able to remember on how to find the horizontal asymptote and how to find the range, what is our horizontal asymptote here? For those who are able to remember. But for us who doesn't know, it's alright. Don't even feel bad. It's fine. Such is life. For us who doesn't know how to find the vertical asymptote or the horizontal asymptote, sorry, it's alright. You will know one day. So, are you still here?
Yes.
Now, tell me, what is the horizontal asymptote? If you don't know, it's fine. It's all, but today you are going to know. It's alright. So, tell me, those people who are able to remember how to find the horizontal asymptote here, what is the horizontal asymptote?
It's 5 over 2.
5 over 2. Now, for those who don't know how to find 5 over 2, when I answer the question using limit as x approaches infinity, it's the same as I'm finding the horizontal asymptote. That will be my answer. Our answer will be 5 over 2. Let's find. The first thing whenever you are solving a question, when we're talking about limit as x approaches infinity, the first thing is, 1, you have to check the denominator. You are following the x which is on the denominator. If the x on the denominator has got only, maybe it's just x, the way this one is 2x, where I'm going to factor out x, both the numerator and the denominator. If at all down there I had 2x, or I had maybe x squared or 2x squared, even if on top I've got only 1x without a squared, it's fine. I'm going to factor both numerator and denominator using the highest power of x on the denominator. So I'm following the denominator, the x on the denominator. So in this case, it is just x. So I'm going to factor out x, both the top part. So I'll say x. So if I factor out x, now sometimes you get confused when we tell to say if you factor out, factoring out is the same as you are dividing. So here we are dividing 5x divided by x, that becomes 5. Next we are dividing 1 divided by x, which is 1 over x. So here is 1 over x. Who is, if I multiply this x with everything inside the brackets, I would get back to that. Who is behind on how to factor? And then you find these things, so you are supposed to know this. Who is behind on how to factor?
We are together, sir.
Nah, perfect. So then the down part I'll follow the same x. Here I'll say 10 over x, that becomes 10 over x, plus 2x divided by x, that becomes 2, because x and x will go. Now this x and that x down there will go. Keep on bringing limits. Now what I have is 5 plus 1 over x divided by 10 over x plus 2. I told you that wherever you are going to find any number divided by x, now we are plugging any number divided by infinity is 0. Now I want to plug in the value. I'll stop introducing limit. I'll say equal to 5 plus 1 over infinity divided by 10 over infinity plus 2. 5, 1 over infinity, I said is what? 0. 10 over infinity is 0 plus 2. The answer is 5 over 2. Here we said the horizontal asymptote is 5 over 2. Horizontal asymptote and the answer for limit as x approaches infinity is the same. So if the time we're going to be revising, especially if we're going to be meeting physical, if our Bishop and coaches win, we are going to talk about, we are going to go back to revise on vertical asymptote and horizontal asymptote. If you didn't understand, we are going to introduce this to find what? The horizontal asymptote, which is the same thing. We are going to use this to find the range, which is the same thing. Because the range in this case, I'll say y should not be equal to 5 over 2. Simple as that. It becomes so interesting if we have got a certain question which goes like this. Which goes like this. Limit as x goes to infinity, then you have x squared plus 1, then you divide that by x. Remember, the deal is on the denominator. So what am I going to factor out here? Am I going to say I'm going to factor out x squared or just x from what I've explained? Sorry? Others are saying x squared. We are following, remember, we are following the denominator. That's the first point. We are following the denominator. So if we are following the denominator, what should come in our mind is, I'll factor out x. So x, if I factor out x here, I'll remain with x plus. Here I'll remain with 1 over x. Because I'm dividing this guy, 1 divided by x is 1 over x. I divide this, I only have x. X and x can go. Limit as x goes to infinity. Now I've got x plus 1 over x. Now I plug in the values, I'll have infinity plus 1 over infinity. Infinity plus 0. And the answer becomes infinity. It's something that is not complicated. As long as you follow the simple principle, then it becomes interesting. The last concept under limits is this, which you are going to find in both 1010 and 1015. Good 1010 math. 1100 and 1120. Yeah, there's not Nezna black ai. Nezna black kuipa. Oh, that's chemistry and physics, eh? Nezna black kuipa. Nezna black monga nija whereby you are in the lib. Wa job wenda keze kapipa bwanji keze kakwizifoka 1100 keze bad. At in 1 hour you are supposed to solve 3 questions as if it's a test. Kaja mnagwa guys, kaja. Okay, it's fine, but let's continue. Kaja keve mnagwa.
Sir, I have a question on the limit. I don't know if you can help me to solve.
Yes, yes.
It is 3 negative 3x plus 3 over square root of x squared plus 7.
The question is saying limit as x approaches what?
Approaches infinity.
Okay. So limit as x goes to infinity of negative 3x plus 3.
Yes.
Then x squared plus 7.
Plus 7, yes.
Okay, so the first thing that I want you to understand is that we are still going to follow the denominator, but the denominator is x squared, right?
Yeah.
So that becomes limit as x goes to infinity of negative 3x plus 3. You divide now in the square root. Don't remove it in the square root time. So you are factoring out in the square root x squared. So you open. Then what are you going to remain with? 1 plus 7 over x squared. Okay, we are now dividing x squared divided by x squared is 1. Then 7 divided by x squared is x squared. You are good there, right? Sorry? So if you can't see the screen, that should be your network. You can just leave the meeting. Now the problem is that when you leave, you're not going to join again because other people are waiting. Once you leave, people will join. Because we're only supposed to be 101. That's the maximum. That's the bad part. But you can leave fast join, then you'll be able to see the board. When you reach at this point,
Just go back a bit. I'm lost.
You are lost. This is
Sir.
you are the same person who was asking this question?
No, sir. I was just listening to the guy asking the question.
Okay.
It's interesting.
It looks interesting, eh? So what we are doing actually, we are following the denominator. So we are factoring x squared in the square root. You get my point, right? So we are now doing limit as x goes to infinity of negative 3x plus 3. On top, I've not done anything. But down here, we are factoring out x squared. Now, if I factor out x squared, it's like I have got this. Now, I'm factoring out x squared, meaning that here x squared divided by x squared is 1. 7 divided by x squared is 7 over x squared. I hope you're okay there. That's what I'm going to replace with here. We are good to go?
Yes, sir. Yes.
Another thing that I want you to understand is this. Do you understand the fact that what I have here, if I have this one here in the square root, is the same as the square root of x squared times the square root of 1 plus 7 over x squared. Do you know that this is the same as that? Uyo guys uyo ashiteko mute mic. Yeah. So if you understand that what I've written here is basically the same as that, then you are good to go. Then another thing that I want you to understand is that, do you understand that if I give you the modulus of x is the same as the square root of x now squared? Do you know about this? If you don't know, then you should know today that the modulus of x is the same as the square root of x squared. So you should know from today. Yes. So meaning that what I'm trying to tell you right now is limit. That's why this is transcended. 3x plus 3 divided by, now what I have here, I'm going to get it as the modulus of x outside. Then I'll say multiply it by, now I have got it, I've remained with this part, which is 1 plus 7 over x squared. What are you saying? Okay, she's not saying anything. We're assuming that she's not saying anything.
Hello, sir.
Yes, yes.
Can you kindly repeat on where you are saying modulus of x?
So I was telling you to say, do you know that the modulus of x is actually the same as the square root of x squared? So this guy is the same as this guy.
Okay.
Yes.
Understand.
Meaning that we have said that what I have here is the same as what I have there. So what I have here is what I have here. Meaning that I have isolated the square root of x squared, meaning that that square root of x squared can be replaced by the modulus of x. That's what I've done here. One thing we should know is that the modulus of x, the modulus will always give us what? Positive answer, not so. Not so. Yes, will always give us positive answer. Meaning that now what we are talking about is, I'm now factoring out x on top so that that x should come and cancel out with that x. Because that will always be positive. That will always come out as a positive. Meaning that now on top I'll say limit as x goes to infinity. On top I'll factor out x. Here I'll remain with negative x, negative 3.
How about that x, the 7 over x, then the x is squared?
Yes, it is squared. That's why I've left it here as squared.
But we won't factor out this x with the squared, we'll factor out the x. Huh?
Which x with the square are you talking about, my friend?
Sir, because you said that we're supposed to factor out the x on the denominator of the highest power.
So we have factored out x squared, which is here now. No, you have not gotten any. Okay, it's fine, but guide, you know the way it is. You guys are 100 here. So at least if 90 can understand, then we are okay. At least 10%.
No, sir.
At, at least 10%. At least 10% of you should be confused. Then we are okay. So at least the good number should be able to understand. Then that's okay. That's why you are going to realize that if you are learning, let's say, math or maybe chemistry, sometimes even 10% of you understand. But some of you go for class, maybe you are going to attend math. You go there, you don't understand it, you can't even ask. You're just there sitting. You know, I like one of your lecturer who is it Mr. Monde? He'll give you examples, 5 examples, he'll say choose 2.
Yeah.
That one is good.
Is it?
That one is good, it's power.
Yeah, you tell you choose 2. So you can choose the hard ones. But still,
Sir, answer the question. Me, I even forgot the concept.
okay, sorry. So now here, let's put now this negative 3x plus, now we are factoring now x because we already know that the modulus of x will always be x. It will give us as a positive. So I'm factoring out x, open brackets. If I factor out x here, x divided by negative 3x, that gives me negative 3 plus this will be 3 over x. then I divide it by this. The modulus of x will still be x. It will be positive. But if you want, you can leave it in modulus. It's fine, but it's going to be positive. Then I reach at that point, it will be like this, x squared. Now at this point, this x and that x can go. If you want, you can leave that one as in modulus. It's alright. Then you can still cancel because you know that it's going to come out as a positive. If you cancel out that, you remain with limit as x goes to infinity, negative 3 plus 3 over x. You divide that by the square root of 1 plus 7 over x squared. At that point, I can now plug in limit infinity is equal to 3 plus 3 over infinity. You divide it the square root of 1 plus 7 over infinity squared. As long as infinity appears down there, it is 0. Whether it's just infinity or power 2 or power 3, equal to, stop introducing limit, stop it. Then from here we'll say negative 3, this guy will give me 0, plus 0. Divide it by the square root of 1, this guy will give me 0. Leave it. The square root of 1 is 1, and the answer becomes negative 3. As simple as that.
Thank you.
As simple as that.
Sure.
Sure, eh? Okay, another sure. Okay, then another interesting part is this, guys. There is one concept which has remained now. One part which has remained is when limit is approaching 0. Okay, it becomes so difficult when x is approaching 0. That's what we need to know. Okay, so for example, if I have got limit as x goes to 0, then I've got 1 over x. What I want you to understand is that whenever we're talking about limit as x approaches 0, we are because if I plug in 0, it's going to be undefined. So we are not necessarily talking about 0, but we're talking about the number that is closer to 0. Get me right there. So as x goes to 0, even the same thing where we're saying x goes to 2. Initially, when you say approaching, when we use the word approaching, you're not necessarily saying it is 2, but as x is getting closer to 2, which is approximately the same as 2. Now, when it comes for 0, 0 fails. Because if I plug in 0, I can't manipulate it. It's going to be undefined. I can't run away from it. So when x goes to 0, like for example this question, what I have to do is I have to check, is limit going to exist or not? How do you know that limit is going to exist? You can only know that limit is going to exist if limit as x goes to 0 from the left side of f of x should be equal to limit as x goes to 0 from the right side of f of x. It can be any number, not only 0, if you want to test if the limit exists. Okay? Now, what I'm trying to tell you guys is this. 1 over x is approaching 0. We are going to get a number that is closer to 0, but not 0. Which number do you think is closer to 0, but not 0? Give me an example of a number that is closer to 0, but not 0. 0.1. Other people can tell me, is 0.9 closer to 0?
Yes.
Madam, you are lying. Are you sure? Madam, are you sure? Madam, are you sure 0.9 is closer to 0? Madam, you are not sure. So 0.9 is closer to 1. Yeah, it's closer to 1, but 0.1, 0.01, 0.001, 0.00001. Do you understand the fact that limit as x approaches to 0 is the opposite of limit as x approaches infinity? If limit is approaching infinity, we said it gives us 0, right? That's what we agreed, not so. If maybe here it was limit as x approaches infinity, the answer is 0. Now the opposite of limit as x approaches infinity is limit as x approaches 0. So when x is approaching 0, it can either be positive infinity or negative infinity. Let's try 0.001. If I plug in 0.001, the answer that I'm going to get, it is actually 1000. If I keep on going, if I get 0.00001, I'll get a very big number. Now this very big number, for us to make things simple, we just say if the answer is positive, we get it as what? Positive infinity. So in this case, limit as x approaches 0 is positive infinity. But I want you to know one thing. Does the limit exist? The one that we have gotten here, the one that we have used, now we have to use two things. I'll say limit as x goes to 0 from the left side of 1 over x. Then the answer that I'm going to get, it should be 1 over negative 0.0001. The answer will be negative what? 10,000. Negative 10,000, that becomes negative infinity. Now, if I go limit as x goes to 5, to 0 from the right side of 1 over 0, now that is now positive, right? 0.0001. The answer will be plus 10,000. That becomes positive infinity. When you find that this is the answer, if the question is, does the limit exist? What will be the answer? Does the limit exist? It doesn't exist. Exactly. So now limit as x approaches 0 from the left side is not equal to the limit as x. Exactly. Now we use Are you sure? Are you sure that phone is just okay? Are you sure? Are you sure that phone is okay? Are you sure? Okay, cool. Now, guys, that principle that I've given you, it is the same principle that we are going to be applying if at all you cannot manipulate a function for you to eliminate anything to make the function to be defined. For example, if I give you limit as x goes to negative 1, okay, of 1 over x plus 1, because if I plug in 1 direct down there, I'm going to get 0, but that is going to be undefined and I can't manipulate it. So for that case, you have to do two things. You have to do limit as x goes to negative 1 from the left side of 1 over x plus 1, and also limit as x goes to negative 1 from the right side of 1 over x. So now you are actually getting the number that is closer to negative 1 but from the left side. When that number you plug in, if the answer that we are going to find here is the same as the answer we are going to find here, we are going to conclude that the limit exists. So when you're talking about existing limit, we're not only focusing on 0, but if I can't manipulate the function so that I should plug in the values. For example, this one, I can't manipulate it. I can't make this function defined. Then I have to check if the limit exists. Simple. Now let's get the number that is closer to negative 1 but not negative 1. Hello? Let's get the number that now look at this. Do you think negative 0.99 is closer to negative 9 from the left side? Not so. Inyaboza, eh? You know, when you're talking about negative, we need to be.
0.99.
No, I want you to understand one thing. Do you know when we're talking about negative numbers, sometimes they can confuse you, okay? Because I'm supposed, like when we're talking about minus, we are getting a number that is closer to negative 1, but again, that number should be less than negative 1. You know what I mean, right? Because I wrote here negative 0.99. Initially, this is greater than that one. You have seen, right? Are you getting my point? Initially, the number that I can get that is closer to negative 1 from the left side, what number do you think we can get? TN Kaid, fast. The number that is from the left side, 0.
Negative 1.2.
Sinaende kutari hiyo. What of negative 1.01 or 0.001? Isn't this closer to negative 1? Okay, even the same one you talked about is fine. You said negative 1 point what? What did you say, madam? Okay, negative.
1.2.
Okay, let's get negative 1 point, because point 2 is a bit far, but negative 1.01 is closer to negative 1, because if I round it off, I'll still get negative 1, not so. So let's get this one. Okay, so now if I plug in the value 1 divided by negative 1.01 plus 1, what answer are we going to get? If you have got a question, you can just ask.
Sir, when you say approaching from the left side,
Mhm.
from the left side,
Mhm.
coming from negative 2 going towards negative 1,
Yes.
haven't you passed negative 1 if you keep going that side? Like, if you say negative 1.01, haven't you gone past negative 1 if you're coming from the left? I don't know if it's making sense, but yeah.
Okay. Let's try to forget for like the negative. Let's assume that we had 1
I'm sure it's 2.
is 2, right?
You have to use negative 2 point.
So we use negative 2.
Yes, sir, guy, when you're approaching negative 1, it means we are from, like, coming from direction of negative 2 to negative 1.
Yes, we are starting, it's more like we're getting a number that is less than negative 1, of which if you look at negative, so those numbers negative 2, negative 3 going this side, those are the numbers that we are looking for, but that number should be
Yes.
closer to. So now I was looking at it to say, Vasa, if I get negative 2, quite okay, it's okay, but if I get negative 1.01 and negative 1, which number is less between negative 1 and negative 1.01?
Negative 2 is less. I think negative 1.01 is closer to 1. Negative 1.
Are you trying to get the logic there? I want you to understand it before we go further. Yes, negative 2, you are not wrong. I can get negative 2 is fine, and the answer is going to be the same. But I'm just trying to tell you to say, even negative 1.01, it is less than negative 1. Okay, these are negative numbers, so they tend to at least maybe confuse us, but it's basically the same thing. But if you're confused, you can get negative 2 is fine.
Sir,
Mhm.
I think negative 1.01 it's more closer to 1.
Yeah,
Negative 2 it's a bit
it's bit far, yes. Negative 2 is bit far, but if you look at negative, I don't know, sir, the one who was asking, are you trying to get the logic there? Or you are still behind?
This is confusing.
You know the reason why it's confusing is because of negative. But if it was just 1, you cannot be confused. So I know why you are confused. It's because of the negative. We should use the what?
Okay, sir, for me, negative 1.01 is correct.
Okay. In simple terms, let me do this. I want to use, okay, let's do this. In simple terms, when we're looking at this, when we're looking at limit as x approaches from left, what I want you to understand is that we want a number that is less than negative 1. That is the one we want. When we are now talking about x approaches negative 1 from the right side, we are going to get a number that is greater than negative 1. But that number should be closer to that. You get my point, right? So, sir, tell me any number that is less than negative 1. But that number should be closer to negative 1. But it should be less than negative 1. Tell me, don't you think, if I ask you, sir, don't you think that negative 1.5 is less than negative 1?
Yes, it is, sir.
It is, right? It is. So if that's the case, then what are we supposed to do? Then that's why here I've gotten this number here to say negative 1.01, it is less than negative 1. So if I do plus, what answer are we going to get? It will be down there, it will be what?
Negative 0.1.
So negative 0.1 is basically 10, right?
Yes.
It's negative 10. But what I want you to understand is that it's negative 10. But if I keep on reducing the numbers, if I get maybe negative 1.00001, this number is still closer to negative 1. I'll keep on getting a very big number. At the end of the day, what I want you to understand is that as x goes to this, the answer should be either positive infinity or negative infinity. So like in this case, it will be 10. If I put another number, which is because it's not only negative 0.1 that is closer to what? That is closer to negative 1. They are not. They are different numbers. So in that case, when I find negative 10, what should be in your mind is that that should be the number. If it is negative, put negative, then it's infinity. So it's negative infinity. You get my point, right? It's negative infinity. But again, if I go now to positive numbers, can we get a number that is closer to negative 1 but from the right side? What number do you think that will be? Come on, guys. What number do you think that is going to be?
Negative 0.099.
Wait. You said what?
I said
Negative 0.9.
10, 10, 10. A number that is near.
Sir,
Yes.
is there a problem if we like just use whole numbers?
What number do you want to use? The same whole number. Give me an example of that number, madam.
No, sir, like on the previous, while we were looking for negative 1.01, you say that 2 is also okay, we can use 2. So I'm saying if in a case where we use 2, do we have gotten a different answer or would have gotten the same answer?
Okay. Initially, what I want you to understand is you can mute yourself.
Coach.
You can mute your mic. Your mics are still making noise. Okay, cool. So, initially, when we're talking about limits, what I want you to understand is that whenever we're talking about approaching, we need to get a number that is closer to that number. Do you get my point, right? But all in all, I can get any number. I can get any number, even if it's a whole number. But what I want you to understand is that as long as you are going to get this concept, then that will be okay with you. I can get any number that is okay. Let's say we have gotten, because if you get negative 2, that negative 2 is quite far from negative 1, but it can still help you. Okay, it can still help you, but what you should know is that the answer will be either positive infinity or negative infinity. You get my point, right? So if the answer that you are going to get negative, in your mind you should put infinity, meaning that will be negative infinity. So if at all you choose negative 2, it will be 1 over negative 2 plus 1. That becomes 1 over negative 1, which is negative 1. But what you should put in your mind is that initially it's not negative 1. You get my point, right? It's not negative 1. So the answer will be positive infinity. Or negative infinity, sorry. Because you have used a number that is far from negative 1. So meaning that if you use a number that is closer to negative 1, it will give you infinity. So it's fine, you can use that number, but other people when they're marking, but other people I think they can mark. But if it's me, I cannot mark, but other people can mark, I think. But for you to be just on the safe side, I want you to understand whenever we're talking about approaching, we're talking about a number that is closer to that number. You get my point, right? We are actually talking about the number that is closer to that number you are looking for.
Sir, I have a question.
Mm.
Like from the beginning of the session where you said that 1 over 0.01 is close to 0.
Mm-mm.
That's the overall.
Mm-mm. I didn't say that. No. Before you go there, I didn't say that. Did I say that? What?
Okay, then I got it
Yes, you
wrong.
got it wrong. Because 1 over this is definitely 100. So 1 over this is 100.
Yes, it's 100.
Yes, that gives you what? It's more like we're talking about infinity. Mhm.
Yes, positive infinity.
Positive infinity. So now, don't you think that this is basically similar to that,
Yes, it
which is
is.
giving me negative infinity?
So, what case are you getting a 0 when you? Is it when you have 1 over x and then you replace it with infinity? That's when you're going to have a 0.
When you have got 1 over x, then it is
And then you replace that x
with infinity.
That's when you're
Yes,
going to have 0.
yes, exactly, madam.
Alright, thank you.
You are most welcome. So are we together now? I finish this question. hmm Now let's get a number that is closer to negative 1, but not necessarily from the right side. So now in that case we are getting a number that is x is greater than negative 1. So let's go now. Which number can we get in that case that should be greater than negative 1?
0.1.
Okay.
The one which is greater than 1.
Greater than negative 1, but closer to 1. Closer to negative 1, but starting from the right side. But it should be slightly greater than that.
0.1, yeah.
0.1.
So how about 0.99?
0.99. Negative 0.9. Okay, I'm getting you. Others are saying negative 0.9, others are saying negative 0.1, others are saying 0.11. So I want you to analyze yourself. You know, when we're talking about we are actually approaching, so this make more sense than this, because 0 is quite far. When you say positive 0 is, oh, not positive 0, sorry, 0 is quite far from negative 1. But if I say this, if I round it off, this one is approximately the same as negative 1. Maijata, and this number is greater than x, or is greater than negative 1. Still confused? Are you?
Sir,
Mm-hmm.
Negative 0.9
Oh,
greater than negative 1.
yes. This is plus sign. Yes, it is greater than that. If we look at this, which number is big here? 0. So which number is greater here? When I put negative 1, then I put negative 0.9, I put negative 0. This number is greater than negative 1. This number is greater than this. So definitely what number I'm supposed to use here is negative 0.9. So that will be 1 over negative 0.9 plus 1. That gives me 1 divided by 0.1. That becomes positive infinity. Now definitely this gives me negative infinity, this gives me positive infinity. Therefore the limit doesn't exist because they are not the same. As simple as that. As simple as that. That's the basic idea. Using the same concept, go and practice this question, and I'll need the answer now. Go and practice this question. Limit as x goes to, where should x go? X should go to sure. So I want to give you this. Okay, limit as x goes to 2, 4 divided by 2 minus x. Go and solve this. Tell me the answer. And also this limit as x goes to 5 of x minus 5 to the power 2 divided by x minus 5. Go and do this. Isn't this one simple? The last one.
Yes, it's simple.
Yes, we can solve.
No, I want to give you hard one, guys. So I don't want you to have simple ones, guys. But what we have solved, guys, let me be honest with you. What we have done today, you need to some of the limits that we have done today, same concept, you see it like in test 2. Okay, is something that is very important that I want you to not, don't solve this one. This one is too big. This one is for grade 12. It's not for people who are at unza. People who are at unza are supposed to be solving this. Limit as x approaches 5 of guys, mwezotenga mawadi imwe kuma jets tien sovani it one x minus 5 divided by raised to the power 2. I want you to go ahead and solve this one as well, and this one with the other ones that I gave you. So you can take a screenshot, then send it in the group. the award winner, 10. So we end there today. Let's meet tomorrow. We are going to talk about continuity and also the first principle. So I want us at least to have all the concepts for calculus as we are preparing for test 2 and also exam. Thank you guys. So for those who had bad network, I'm going to send the recorded class just after 10 minutes from now.